Hello, everybody, and welcome to DevOps Decrypted. This is episode 14. I'm your host, Romy Greenfield, back from holiday. And joining me today, I have Jobin, Jon, and Rasmus. Hi, everybody.
Hey, Romy. Welcome back.
Thank you. So let's start with talking about maybe some DevOps in the news. I know that there's like a lot of talk about platform in the news at the moment. What are your guys' thoughts about building platforms and their use cases? What's good about them? What's bad about them?
It is such a meaty topic, and there's so much floating around about it right now. That's for sure. I love the idea of having a platform, but you have two camps right now, or rather you have a spectrum of camps. There are those that say that, well, it's just part of the process. You know, you can do one thing, you can do many things, while there's another way where it's more like, don't call it a platform or whatnot. So how do you even start defining it? That's the hard part for me, I think.
That's the first thing that came to my mind when Romy said, let's talk about platforms. And then there's this article which said, don't call it a platform, right? It reminds me of that discussion I had some time back. Should we call it DevSecOps or SecDevOps or SecOps or, you know, so I'm confused. What's in a name? So why can't we call it a platform?
It is just a name. You can call it whatever you want. What's important is what it does.
I think it's important though to have something that you can to actually name things so that you can talk about them. To actually have things that say something that you know what to think. So if you're not calling it a platform, then what are you going to call it? You have to. There has to be something. There's some kind of common vocabulary to actually have a discussion around and know what you mean. So I'm not necessarily sure I agree with the don't call it a platform, but I think there's some interesting ideas in that post, and I think the platform engineering and building like internal platforms is a complex and widely misunderstood thing, I think, and it's possibly something that the industry is really just grappling with to actually understand what it is that we mean when we're talking about that.
Yep, and I can suggest sort of and clarify. I think what we are thinking about, since this is a DevOps podcast, is sort of the next thing, which is becoming more and more about the DevOps platform or the internal developer platform and those sorts of things. There are, of course, previous platforms like Cloud Foundry and other like deep tools that are really meant to do all kinds of things. But it feels like that this new initiative in platforming and platform engineering is new, and it is sort of a next evolution of these kinds of concepts.
Yeah, so I think one of the kind of the key themes in platform engineering and building platforms is that enabling developers and reducing the cognitive overhead. So in my mind, anything that reduces cognitive overhead and kind of allows you to focus on solving the problem at hand, that's kind of that's platform to me, and that's the important part of it. All of the rest of the fluff around it, you know, that's kind of nice, but ultimately it's about giving people tools to build and to operate things without having to have to worry about too many concerns all at once.
If I remember correctly, that was also one of the major arguments in that article. They were focusing on developer experience, right? You call it platform, you call it something else. Ultimately, it has to be about developer experience, right?
Yeah, absolutely. I mean, and I agree a lot with the argument made in the team topologies book about, you know, it's the thinnest viable platform is what you should be aiming for. Certainly at least, like, and if that's just a set of documentation of these are the services or tools that we want to use, I think that's a brilliant place to start. When songs, and it might be that's where you need to end as well. And then maybe not go too much. But I think this is where, like, the context of where you're in is really important, and so the size of your engineering team. Because if you've got hundreds of engineers and you need to make the most of them, then it's probably worth giving them higher level abstractions to build on, so that they can go faster together. Ultimately.
I think the biggest question is, okay, what exactly do we mean by the platform? Is it like a set of tools, or are we actually specifically talking about an internal developer portal as the platform, right? Is it a service catalog? Is it an internal development portal, developer portal? What exactly is the platform that we are talking about?
Yep. And it's going to vary so much, almost infuriatingly so, how that is defined per company. I think the main thing we can maybe agree on is that, DevOps, when it came out on the scene, was really more about connecting, dev and ops naturally. But the way that worked was turning ops slowly into a service-oriented thing, to where it wasn't that stuff was being thrown over the wall. It was that ops defined an interface to the wall, so that you can go up to the wall and request things without having to go and file tickets and go left and right and all those kind of things. So now kind of the next gen of that is, well, maybe there isn't even an interface. Maybe it is just a platform you can go log into and you press the buttons. It's still done by somebody behind the scenes, like an ops team or a DevOps team or platform engineering team. But it's even more smooth than that first pass at DevOps.
You're talking about a fancy self-service portal then, right? Where you can go and probably request your infrastructure, probably even start onboarding your team. A lot of those things that happens through the portal, the self-service portal that I was mentioning about.
Mm-hmm.
But is that alone contribute to the platform, or is it like there's a lot of underlying tools, which could be the CI/CD tools, monitoring tools, all of those contributing back into that internal developer portal? Will the platform be a combination of all of that together?
I wonder if somebody could make a map of platforms where, as a newcomer to the field, they're like, do we need a platform? Here's a flowchart. Okay, let's see which one you get. And if it is just documentation and Confluence, that's good enough. If it's an IDP like Backstage, cool, go do that thing. If it's something even grander or something consisting of multiple independent pieces, sure. But probably that map is lacking, and it's lost in all this kerfuffle in talking about platforms and not platforms and yes platforms and multi-platform and so on and so forth.
You didn't mention about Backstage there. Obviously, you cannot have a discussion around platform engineering without talking about Backstage these days. There was a lot of emphasis for it, even in the AWS reInvent last year. So what exactly is happening in that space? I mean, from what I understand, it is an internal developer portal. I mean, you still need the CI/CD tools. You still need a lot of the other tools that you would otherwise require for the functions that you need to do, the DevOps functions, right? So what exactly is Backstage? And I mean, will that alone, if I'm the customer adopting Backstage, will that alone take me somewhere?
Right. So Backstage at least seems to have the sharp focus on what they are, which is a pane of glass view to your tooling and the stuff going on at your company. So that's your software catalog and all the things in there. And it's a set of templates that get you started when you're trying to do a new thing. Out of the box, it might not be so much figuring out, we are already an established enterprise. We have all these existing things. And what do we do? Well, I mean, you probably already have a bunch of platforms. If you're already established and you've been going for years and years and years, odds are you have platforms. You might not know what they are, where they are, but they're in there. Backstage is a cool little thing where you can begin somewhere in a light fashion. And I believe that just recently they also announced that they were getting ready to introduce their new backend, because it did start when it originally got open sourced by Spotify. It started as maybe a bit of a hodgepodge, just because it's kind of like, we're going to get this out of the door. Here it is. And it went V1, but it still took a lot of just, messing around with code in the app itself to make it yours, which was hard to approach. So now they are getting to where it might have more of a plugin manager like Jenkins or something, which can be nothing but a good thing, in my mind at least. So yeah. I think Backstage knows what it is, but the platform field is still so much bigger than just Backstage.
Yeah, and I think that Backstage in a way is almost a tool to build an internal developer platform out of. It's not an out of the box experience of things, because it each organization is going to have their own requirements and unique context in which they're working. And so it's the collection of the plugins and of the templates and the service catalog and of the various different things that you want to put together for that to be your platform. And in the same way that I think that the Kubernetes is a kind of a tool for building your operations platform. You want to call it that. You have to customize it out of the box. It isn't. You have to have an opinions around those kinds of things. So I think of Backstage in a similar way of it's a starting point to go build, and it's probably not the thing that you finish with, right?
I remember one of the major problems that we have faced internally is everybody liked Backstage, but the developers themselves consider, it's yet another tool, right? Yet another fancy user interface that I need to start using now. And once I started using it, it's great for onboarding teams. It's great for self-service. But at the same time, if I need to make simple tweaks, there is no easy way to do that in Backstage at the moment. You're probably looking at developing another plugin, and for which you need another developer on board who can actually go and do TypeScript and develop a plugin for it. And obviously then comes a maintenance issue. So Backstage itself was becoming a problem internally, and maintaining it was becoming a problem, right?
Yeah, and we've kind of reduced our I guess the ambition for it initially, because everyone was like, yes, we're going to use all the features, we're going to use all the things, all the possibility, and actually reducing it down to a much smaller set of capabilities and think, actually, we're just going to start here and then see where we grow with it, with our Backstage uses. And that's been a lot more successful in terms of getting more teams on board and more teams adopting that. But Backstage as a place to share frankly who's on the team. It's a good place to start, as well as some documentation and things. So it's growing for sure.
There is definitely a large cultural aspect to it. My understanding is that probably part of why it was so successful at Spotify was because they had the culture where every team that was working in Backstage was also working on Backstage. And that works well if your entire tech stack is oriented around Node and those sort of things, but it might be a big pill to swallow for a .NET shop or something else that's just completely out of that field. So if you fit in it culturally and tech stack wise, you can turn Backstage into whatever you need, and it can cover probably all your platformy needs as long as you connect it to the right tools and integrations around it. Whereas maybe some of the other options in the market, they might be a better fit tech stack wise, but they could be trying to be everything when they're not, and they aren't extensible to where they can be. And maybe that's where some of these don't call it a platform things comes in, because if you can't truly make it into a platform that fits uniquely you, maybe it isn't a platform, or maybe it isn't a platform that you need.
Yeah, it goes back to that build it or buy it argument, right? I think Netflix, when they started the platform engineering project, they looked at Backstage and they realized that instead of investing all our resources and money into, maintaining Backstage, it's probably better that we create an internal developer portal ourselves. And that's the route they take, right? They actually built a different portal, didn't rely on Backstage. And even at the end of it, they found that the adoption internally was a bit difficult because users thought that, again, as I mentioned earlier, it's another user interface. But at the same time, they found out that just consolidating everything into single place is not enough, right? You need to build your workflows using the tools so that the adoption is easier. The developers you need to get the buy-in from the developers. Otherwise, it's all pointless.
Yeah, this also gets to where I have an issue with some of the naming of IDP as internal developer platform, because sometimes it's suitable to make it about the developer experience, that is developer first. It's pretty much nobody but developers. But in some cases, like with Backstage, you can make it a thing that PMs and leads and things rely on to keep tabs on things, but they might not really count as developers. And it's, again, going to be so uniquely suited to different companies that it's hard to get there. One thing I started wondering was, instead of an internal developer platform, is it more like a developer community? Because that can sort of include everybody that's in the picture of developing software, whether they're a PM or they're actually in there coding on things.
That's an interesting concept. Let me ask you this question, right? When we say IDP, a lot of people say it's internal developer portal. You just mentioned it as internal developer platform. There itself, you can see two lines of thoughts, right? What exactly is it, right? I mean, obviously, if I'm looking at something like Backstage, I see it as an internal developer portal because, it is at the end of the day a portal, and it's not a platform because it's not hosting anything else. All the tools that's running behind, it's all it's not part of the system itself. So it's nothing but an internal developer portal.
Yep. And the wording has been so meshed up that I'm using them interchangeably by accident anyway. Yeah, I'm pretty sure Backstage is portal. But then in some cases, it's like developer or DevOps. So is it like an internal DevOps platform or internal developer portal? I'm sure some people have a definition for it, but I don't think that's out there firmly anywhere yet. So sometimes for me, at least, I like let's just call it something less overloaded and just try to make it more clear.
Makes sense. Another discussion that I was looking at was, are there enough tangible benefits to say that, yeah, it's worth exploring platform engineering, it's worth investing into it? Because one of the reasoning was that a lot of the benefits that we can actually count or quantify, it comes from the proper implementation of DevOps processes and tools, right? Continuous integration, continuous deployment, that actually brings benefits that you can quantify. Whereas with platform engineering, yeah, great, you are implementing a set of standards, a set of same processes to things like that, but they can't really quantify it. And again, you need to say that having a platform team looking at platform engineering, that comes with a cost on its own, right? So looking at the cost versus the actual benefits, is it worth doing it?
Well, I think in my mind, this is part of the thing of measuring and understanding where your organization and where are you spending time, where are engineers spending time that they shouldn't be, things. And it can be that one of the problems you have is that you don't know what your estate is of all the services there. So that the most important thing is to get a service catalog and understand which teams are running which services and what capabilities do they provide. Because in surfacing that information, you can then see what are the new capabilities that we can serve our customers with by combining the different services. So that might be one area of problem that you have. Another area of problem that you might have is knowing what are the choices you have to go when you go and build a new thing. Like it's the kind of the blank sheet of paper problem. You like to have a template, have something as a starter, which you can go things. It gets you going more quickly. It means you're more likely to adopt good practices and the standards that the organization might have. And so I think that's kind of that's another area. Another thing would be like around the standardization and like, oh, this is just how we do things. And so those things actually having a set of these are the blessed services. This is if you're going to build a web service, this is how we do it here. And that being, and this is how we manage it. So you might have even your own custom CLI to deploy things, and you have a single path to production. You have a single tool chain. It's likely that organizations are going to have a combination of those sort of three areas as problems, and there's plenty more I would imagine as well. But when I think about it, that's the level of complexity that you when you start thinking about how are we going to get more out of our teams? Like how can we remove busy work? How can we remove frustration? It kind of gets down to how can we make teams' lives like happier? Like how can you be more happier? So you're actually doing what you love doing, rather than battling some. It's like I've got to learn a new thing, or I've got to apply like the security standards to this project, and I didn't have a template to begin with, so now it's super painful to add all the things that I did, and I've got to do a ton of refactoring, and it's just slowing me down getting value out. So I think that those are the areas that I think about in terms of platform and enabling teams to do more, and at a higher quality.
So that's another one of the interesting parts that at least one of these articles recently touched on. I think it was by Humanitech, which is one of the other IDP options out there. And they got into literally trying to calculate an ROI on the different activities that your team perform. Because Backstage looks shiny out of the box, but if you just think about, like, I can press a button and I can get a Git repository that if it's hooked up to GitLab will deploy an app, like, yay. But if you start doing the math and like, how often do you actually spin up a new environment or a new app? And it's like kind of a disappearingly rare activity. And what they came out with was saying that the most important part to really get results was implement basic CI/CD. Was like, yeah, that's right. But that's like way before you would think that you start thinking about portals in the first place. So maybe it is a good exercise to first go in there and calculate, well, what are you actually tied up in? What are you toiling away at? What is taking too long? And maybe there's a platform or portal or something that can help you. But if the problem is that you still haven't got automated testing, you probably should work on automated testing first.
Yeah, I think that word toil, I think, is a really important one, and there's also about capability as well. So one of the things that a platform can do is fill in for a lack of capability for a team. So you might not have great operational capability, but you can lean on the platform to deliver that for you. That might be something that you're then able to enable different shaped teams to running and deliver. So yeah, I think that toil thing was maybe what I was talking about before, but the capabilities as well. It's sort of standing on the shoulders of giants in a way. Like that's another way of thinking about it.
We've actually started capturing all of the unplanned work that we end up doing, that maybe having some kind of tooling or automation across all of our different microservices would help with, because we were realizing that we were doing a lot of work that wasn't tracked in a sprint when we needed to upgrade dependencies, vulnerabilities came up, and we weren't actually tracking that. We weren't apportioning any estimations or time value to that, when actually it was taking up quite a lot of our sprint. And so at the moment, we've just started measuring that and actually putting estimations on how long that work takes to see how big of an issue it is. And then it makes it a clearer cut argument for, well, actually, are we doing this in the best way? Do we need to bring in some kind of automation that's going to go and update all of the different microservices to make sure that we don't kind of context switch, do one service at a time, have things in different states?
Yeah, and I think that's kind of one of the things I recommend to teams to do. It's like your first thing, and then you can spend the time paying down the technical debt, and then see some results maybe, and I think that's, it's super important to do that measure. It's kind of just look at basics of flow metrics of where is work waiting and why, and what's kind of holding you back.
Yeah, I was going to touch upon that. I mean, the problem that Romy mentioned, any IDP is not going to solve that problem, right? So you need to realize where your problems are, as you mentioned, where the toil is, where the wastage is. So are we saying that, probably it is worth doing a value stream mapping early on before you venture into, doing proper platform engineering or whatever it is, right? Because you need to know where the wastage is, how good the flow is, and those kind of things before figuring out, okay, where's the problem? What's the solution to it, right? An IDP may not be the solution, right?
There's also a fun catch-22 involved in it here, because as Romy noted, they've started capturing some new metrics. Okay, where do you put the metrics? Oh, well, we need a developer portal for that. But we don't know yet if that would be worth it because we don't have the metrics.
that's what possibly the value stream mapping will bring out, right? It will bring out some data and some focus points where you can then start investing time. If it is a metrics that you're after, yeah, definitely go for it, right?
It is definitely a fun challenge.
So I've seen in the news that Google have announced something called Service Weaver. What are everybody's opinions on this new framework for writing distributed applications?
Ooh, there's another fun one. I think Jon has thoughts on this one.
I certainly do. I'll be frank. I hate it. I hate the whole concept of hiding the fact that you're actually got a distributed application behind synchronous APIs, like or even asynchronous APIs that sometimes I've got like this is sort of super local speed, and sometimes I end up with a remote call that could error and hit rate limits and all those sorts of things. And I think it feels like one of these problems that we've time and time, like the industry has run into everything like frequently. So it seems like about every kind of 20 years or so, we go through this cycle of, oh, we could hide all of the remote procedure calls behind things and make that will be easier to work with. But it's not easier to work with when you hit production, because like the real world happens and distributed calls fail, and anyway. So I think it's one of those well-meaning things which I kind of feel is like really dangerous. I'd love to be proven wrong. I'd love to have them got it right, and it's not an issue. But yeah, it seems like a dangerous paradigm to go working in, really. Anyway, I hope I'm wrong.
I want to confirm though. So from what I read, what I understood was, okay, we are going to end up with a single binary, right? At the end of the day. So it's going to be a monolithic application, although while developing you're doing it just like you develop microservices. So if it is going to be a single binary, again, there were a lot of advantages to microservices in the way that you have these services deployed in different places. You can scale them differently. Like if I have a login application and a billing and something else, my billing and login is probably used a lot more than the other applications, and you need to scale them appropriately. None of that is going to happen with a single binary, right? I mean, you still are going back to the old world order where you have to figure out how to scale this application with a single binary.
Well, and so I think that's one of the things that this does quite well, actually, is it divides things into modules, and those modules are those units of deployment that can be deployed independently, but
okay.
and you can kind of combine some modules together for things. So it gives you that level of control. So that in a sense that I think that's a really positive part of the framework. So not to be completely hating on it, but what that gives you is it gives you the option to be more creative at runtime, and to as you scale, you can go, well, actually, yeah, this the billing part, let's separate that out and run it in its own set of services. So
yeah, I should have known. Google did it, so they must have done something right.
Yeah, and I think it's so the other thing behind it, I think I want to acknowledge there's a lot of smart people behind this as well. So hating on it, but I do want it to succeed as a way of looking at things, because it would, if they're right in this things, it would simplify writing a whole load of things, because it's much simpler to think about things as a contained unit of deployment. And to have, well, when I make one change, I can make like an atomic change over things. So that simplicity is super attractive.
I don't know if I mentioned this in this podcast before, but I moonlight as an indie game developer in open source land. So I'm very familiar with a problem that is common to game development. And I see this Service Weaver thing and I go, aha, I could totally use this for making games out of. But that's probably not what they had in mind. But it brings me to this concept where in video game development, you're dealing with a monolith, at least if you're doing something like single player, because it's literally a full screen application that is running on somebody's computer. So yeah, everything is in one binary, and that's how it works, and it works really fast. Then when you mix in something like multiplayer, which is where you get your remote, calls and so on, it gets complicated. And sometimes you fix that by having a completely separate set of components for when you run in multiplayer. And they're the ones that have all the network communication things hooked in. But then you have this weird difference where you have the monolith, which just works beautifully, and the multiplayer thing that's modular, and you get different bugs between the two of them. Sometimes you fix that by cheating and actually making the local binary itself run a multiplayer server, and you just connect to it, which adds a lot of overhead, but at least makes them similar. So me seeing this framework makes me think, wow, so could we just write one thing? And then just if we say, okay, now we want to run the game server, but in Kubernetes, and it just like pulls out the right pieces and just makes it magically work, that would be wonderful. I would love that. But I kind of also wonder that that's probably not the right use case. And I might be a little disappointed also in when some of the magic turns out to be like people hiding behind curtains with little long rods and they're like shifting the doors around.
So, Jon, my question then is, what can Google do differently to make this more attractive to you?
I think it's the things that could be remote calls. They need to be really explicitly remote calls, and to have those that kind of constraint around it. So if you're in if you were in kind of Rasmus's game developer kind of platform, the difference in performance from everything running locally on your things to part of it is in the is in the cloud somewhere, where it's running on some server that you then need to maintain and synchronize state between. The number of calls and the amount of chattiness on a protocol like that would be, that's really important to get right. That your client part has got enough of the state that matches with the with the server and those sorts of things. So I think bringing in that explicitness of the remote calls, the error handling, that kind of thing, I think would be really helpful. One of the things that I think they have got right, and they're looking to get right, is the instrumentation and the monitoring around that. So you will know when your remote calls are failing, but just feels like the APIs aren't really there. It's written in Go, right? So you can handle the error, but a lot of the time when you're writing distributed systems, you want to handle the error and do some back off and retries and propagate failure and you use kind of distributed systems error handling methods, and it just doesn't feel like, it feels like that's too hidden from you. And sometimes you don't care. Sometimes you just want to write a library, and if something fails, then that's kind of okay. But you need to be able to get it right there to your fingertips to be able to do that when it matters. And so maybe one of the, I haven't seen it in this, but maybe something that could be added, or someone's going to tell me it's already there, is like an injection of errors. So to be able to throw some noise in there and make it feel like when you're developing locally, make it look like you're actually in a distributed system that's going to require a retry to somewhere, or a transaction failing halfway through, and then it retries it to another copy of the service.
So I'll throw in another thing that I would love to see, and I don't know if it's there now or if Google would want to do it, but this really makes me think of, again, how the framework or whatever the platform can be the best thing ever, but if you're not mature in the different areas, it may not matter. So in this case, the concern is that it might be too slow if something is just transparently suddenly remote. A way to get around that, I would think, would be just extremely high coverage automated testing, and making it really, really easy to get to it, so that everything you write in there will automatically have tests generated that would run with different levels of latency, almost like a built-in chaos monkey that is going to get you that, like, okay, we're going to see how this beautiful thing that worked great on your thing over here works if we throw all the components in the cloud, and then also throw a monkey wrench in there and see how it does it. If you get that somehow out of the box, then if you can kind of like fail fast and learn immediately, like, oh, wait, this thing, when it runs remote, just completely screws up everything. But we got told by the system almost immediately, because it came with all these handy helper functions to make automated testing a reality and making it easier. Because honestly, that's one of the usual things that go missing. You just don't have thorough test suites. If you do, that helps so many things, but it's hard to get budget or focus for that.
Interesting. Yeah, looks like, that's another framework out there that developers can now go and take a look at, like we don't have enough frameworks.
Yeah, always need more frameworks.
So this discussion reminds me, there was a post a couple of weeks ago about increasing complexity causing cloud outages, and I don't necessarily think it's the increasing complexity that's the problem. It's when it exceeds people's capacity to hold that complexity in their head, in the thing. And if you're trying to hide complexity in places where you actually need it to be explicit, I think that's the problem. So and this kind of links together the conversation with platform engineering as well. If you've got a platform that can reduce your cognitive overhead, and I think removing that, like it's a way to get a more stable, more reliable system. So I don't know what you guys think on that, but it's one of the things I think about.
Yeah, I think it's at the end of the day, it's all about abstraction of how to hide that complexity, right? Part of the problem is we always look at platforms or the other frameworks as a solution to hide the complexity, but the complexity is still out there, right? You talk about creating cloud agnostic solutions, and then you have multiple clouds. You're talking to Google Cloud, you're talking to AWS, you're talking to Azure, all of them there. And there are various technologies that you're using. So I think you need a team of people who is experts at all of this, which is never the case. And then suddenly you have a problem at hand because something goes wrong and you don't know whom to pull in. How many different places to look at?
When we've had some outages recently, we thought that we understood the service that we're using, and so the complexity comes from actually there's some caveats to the service that we're using. You've read all the documentation, you've tested it in staging, and then there's one edge case or there's one little caveat that you didn't realize, and then you can write your tests for that, you can test for that in the future, but until you actually run that in production and everything falls over and you're like, why? And you're messaging AWS saying, we thought we knew how this worked. What happened? And sometimes they take a long time to come back to you and explain, actually, this is how this works. And this is a limitation that maybe we haven't publicized as much. It might not be obvious. It could be in some documentation, but it's not in what we just happen to have read when we were trying to build the service and what we tested. So there's the complexity on like the actual infrastructure that we're hosting everything on as well, that for one developer to know all of that is highly unlikely. For a small team of developers to come across that without having that edge case experience once in their life before, it's very unlikely. So yeah, lots of outages caused by these little nuances that we just didn't know about until it was too late.
Yeah, and those edge cases are always going to be different for different services, different cloud providers, right? And that makes it even more complex. I think there was this interesting statistics, 1 in 5 systems always go down because of the cloud complexity, and how outages are something that is really bothering all the infrastructure providers. So it's quite interesting.
So I'm going to throw in something here I'd like to make out as being clever, but maybe I'm more clever than I give myself credit for. I think all this is very cyclical, just like what Jon was talking about earlier, that every X years, you just find a new thing and you add complexity to it. And I'm going to also be nerdy and tie this back to platforms. And again, being an indie game dev, because once upon a time, when I started with a group of people, we were worried about writing like renderers, really low-level stuff that's hard to do, it's complex, and so on. And then eventually, like game engines, much like platforms, started coming out. And they kind of just abstracted some of the complexity behind your libraries or your engine or your platform, or in the case of cloud, which is really just somebody else's data center. It's still there, but now you're just building this increasingly high tower of madness, like that famous internet graphic of what keeps the internet running is this one guy and often a stake maintaining this little teeny tiny open source library. And you may get better tools, but if you keep doing things process and people-wise the same, you will just repeat the mistakes of the past over and over and over again. So to me, it becomes almost more like, how do you break the cycle? How do you jump out of that loop? And I'll bring this back to saying that automated testing and Chaos Monkey and those kind of things, and having like a healthy overall balance between things might help that. Because you will be less surprised at things that go wrong you hadn't pictured if you throw a Chaos Monkey in there and have testing that'll be able to catch it more readily. So it's easy to get stuck on that kind of like the incline of tools and the productivity and so on, but you only ever still advance in one thing. Oh, now we can do more things faster. Yay, let's do more things faster. And then you look at like graphs of productivity over time, and like productivity is going up, but revenue is not going up. How does that work? And it all just comes back down to, well, maybe we need to be more balanced. Maybe we need to not just focus on doing things faster, but also doing them better and bringing people in and having them involved and knowledgeable about all these things. But that's probably hard for especially for-profits to do, because it's the thing that gets, short-term quarterly returns made more visible that gets the attention. And stuff like writing good documentation or automated testing or having your value stream maps and things like that well documented somewhere, that's not what gets attention.
Yeah, I think it's hard to do, but it's also, if you don't do it, you're going to die in the things. And I think that kind of sort of mindset of a team that are looking to continuously improve and have that sort of agile, adaptive mindset of like, let's question things. Let's not think of any of our practices as being immutable or like best and final. We're always looking like, what can we do to improve what we're doing? Can we look at examine how we do things and do things differently? And I think this is where like DevOps as a whole thing is come from. It's all about, we're not going to stand still and just accept that this is how it has to be. And I think like looking at complexity and looking at how can we make sure that we understand as much of the complexity as possible. So do we have the observability in place? Do we understand that? At the same time, do we understand where our team is spending time? Like where is the toil? Where's the unplanned work? Where are all those kind of things? And that taking that observability mindset and going, let's apply that to our team as well, and maybe let's apply that to the incoming work that we got, or maybe what we need to do is apply observability across the entire system that is the team, the work that we're doing, and what's happening in production, and have like a huge holistic view of things, or different things we're sort of thinking about to try and understand different layers of complexity that you can end up running into.
So in other words, it's not all about the tools. People in the process.
That's it for today's episode, episode 14 of DevOps Decrypted. Connect with us on social at Adaptavist and let us know what you think of the show. But from myself and all of our speakers today, thanks for listening, and we'll see you next time on DevOps Decrypted, which is part of the Adaptavist Live podcast network.